Hello students, in this lecture we will discuss about torque and those factors on which the torque depends on. First, the definition of torque. The turning effect of a force is called torque. It means that the turning effect produced in a body about a fixed point due to some applied force is called torque. Let's take an example of spanner that is used to loose or tight the nut. We may turn the nut with fingers. It is difficult to do this job, but we can do this job very easily by using the spanner. And if the spanner having a long handle, we can do this job much easier than the one having small handle. Please note that the torque is greater by a force using a spanner of larger handle than the torque produced by the same force using a spanner of small handle. Hence, tightening the nut by a larger handle spanner is much easier than the small handle spanner. Here we notice that the torque not only depends on the magnitude of the force, but also depends on the length of the moment arm. So if greater is the if the length of the moment arm is greater, then the torque would be greater. And also, if the magnitude of the force is greater, then the torque would be also greater. Mathematically, we can write the torque as the cross product of two vectors, force and moment arm. So it means torque equals to moment arm cross force. Because this is the cross product between force and moment arm, so the third vector which is produced as a result is also a vector. Hence, torque is a vector quantity and its unit is Newton meter. You may define 1 Newton meter torque as that a torque of 1 Newton meter is caused by a force of 1 Newton acting perpendicular to the moment arm of 1 meter long. Let me write again the formula of torque, and that is tau equals R cross F, which further can be written as tau equals R F sin of theta. As the lever arm is defined as, it is the amount of perpendicular distance to where the force acts. So it means that there must be a 90-degree angle between the line of action of the force and the lever arm. Please note that the line along which a force is acting is called the line of action of the force. And the perpendicular distance between the axis of rotation and the line of action of the force is called the moment arm of the force. As you can see in these two figures, the line of action of the force is at 90 degrees to the lever arm. But in these two cases, the lever arm is passing through the handle of the spanner. But what if the force is acting at some angle theta with respect to the handle of the spanner? In that case, the lever arm would be here, which is shown by these dotted lines. But it is exactly following the definition of lever arm, and that is the amount of perpendicular distance between the line of action of the force and the axis of rotation. In the case if we have a force at some angle theta with the handle of the spanner, we have two ways to solve that problems. In the case if we want to take the force and resolve that force into its components, that would be the first way. And the second way is to resolve the lever arm into its components. We will discuss both cases in detail on next slide. So in case if we are resolving the lever arm into its components, in that case we have a formula tau equals R perpendicular F, where R perpendicular is the moment arm or the lever arm, the perpendicular distance from the origin to the line of action of the force. And in case if we are taking the case of F perpendicular, then we have tau equals R F perpendicular, where F perpendicular is the component of the force perpendicular to the line drawn from the origin to the point of application of the force. To understand graphically both cases, let's take an example of wrench. As you can see in this figure, if first the force F If in the first case we are discussing this one, then let the force F acts on range at point P, whose position vector relative to the pivot O is R, as you can see in this figure. Because force F makes an angle theta with the horizontal axis, so it can be resolved into its rectangular components. The one component is F cos of theta and the second is F sin of theta. The torque due to F cos of theta about point O is zero because its line of action passes through this point. Or in other words, we can say if F cos of theta is along to the radius is along to the R. So the torque is zero, but F sin of theta, the component of the force which is perpendicular to the R, is only responsible for generating the torque in the body about this point O. Hence, we write the expression tau equals R F sin of theta, where this F sin of theta is this perpendicular component of the force. Now if we take the moment R and we want to resolve that into its components, then in that case, the only component which contributing to the torque, that is R sin of theta. So in that case, you can see in this figure where we extended the line of action of the force up to here, and we take the perpendicular from the axis of rotation to the line of action of the force, uh, keeping the 90-degree angle between both axes, where distance from here up to this point is nothing but the moment R, and that is R sin of theta. This you can easily do by doing the vector calculus, where you can see if we extend the R up to here and keep the force in this direction and keep the 90-degree angle between the perpendicular and the force, then by resolving the R into its components, we get this axis, and that is D equals R sin of theta. Hence, ultimately, we get tau equals F R sin of theta. Here, R sin of theta is nothing but this perpendicular component. That's the reason we have written tau equals R perpendicular F. That's all for the today's lecture. Thank you very much for watching. I'll request you to please share this lecture with your friends.